So this video is in response to a question that I was asked in one of our WhatsApp groups. You can always join the discussions that are going on in our WhatsApp groups. So the question was about waves and specifically superposition. So you're supposed to know here that two waves are in superposition if they are in the same physical location in the medium they are moving through. This could be air or any other medium. When waves are in superposition, their amplitudes add together to produce a single wave with a single amplitude. After they are in superposition, they move away as if they never interacted. So you should know that waves can interact. For example, here you can see waves moving, and when they move close together, the bottom part there in blue is showing what would happen if waves of different amplitudes in opposite directions, such as that, interact. The other one with a positive value of amplitude, and the other one with a negative value of amplitude. So you can see that they cancel each other out. So they can continue to move, and we are saying they act as if they never interacted. So this is what would happen as waves interact. And we have what is called constructive interference of waves and destructive interference of waves. So constructive interference is when two amplitudes in the same direction add to produce a larger amplitude, and destructive interference is when we have two amplitudes in the opposite direction cancelling each other out to produce a smaller amplitude. So you can check there. So let's have a better example here. So let's say we have two waves that are going to be interacting. So we are going to show wave 2 moving into wave 1, and we are going to calculate the resultant wave, the resultant amplitude from the interaction of those two waves. The highest point on wave 2 there is a +2. So I still have that. But as I move into this region, check what has happened on the resultant. Here we are saying wave 2 has an amplitude of +2, whilst wave 1 has an amplitude on that particular location of -1. So if we add those two, we are going to say +2 - 1, and we're going to have a resultant of 1. So I also want you to follow that. If you follow that largest amplitude of wave 2 as it gets into wave 1 there, you realize that in the resultant wave we now have a total amplitude of 4. So this is a constructive interaction in which the amplitudes add up. So 2 + 2, we get a total amplitude of 4. But if you check the region immediately to the right of that, on wave 2 there and wave 1, we have an amplitude of +1 with wave 2 and an amplitude of -1 with wave 1, and they cancel each other out. +2 + 1 - 1, we get a 0, and that's showing on the resultant wave there. And with every other region, you can see that the last region of wave number 2 has an amplitude of -1, and on that particular region we have an amplitude of 0 with wave 1. So -1 + 0 there, we have -1. So let's continue to move the wave into wave 2 into wave 1. So what has happened now, if you follow this, the largest amplitude for wave number 2, as it gets into that region, wave 1 has an amplitude of +1. So we now have +1 + 2, and the total amplitude in the resultant wave there is +3. As I move the largest part of wave 2 out there in the resultant wave, we have a +2 there, and on the region where I have immediately to the right of my largest amplitude on wave 2, I have an amplitude of +1, and on that I also have an amplitude of +1 for wave 1, and the resultant in the resultant wave there is +2. If you check, I also have a +2 in the resultant wave for the third region to the right of wave number 2, where we have a 0 amplitude for wave number 2 and +2 for wave number 1. So the resultant there is 2. So this is what happens as waves interact. So let's continue to move it out. You can continue to do the math and see that what we are simply doing is add to get the resultant. We can also demonstrate this using sine waves. So those were square waves. We can show the same pattern with sine waves. So you should know that there is something called phase difference. I'll do a video on that if you don't know what it is. So the question says what will be the amplitude of the superposition of these two waves at 5 seconds? So if we mark 5 seconds there, we have an amplitude of +2 on that wave. And on that same region, we have a different amplitude, which is -4. So what would be the resultant? We just say +2 -4. So we just add, and our resultant is -2 at a point of 5 seconds. This wave is superimposed on the same wave phase shifted by 2 pi. Draw the resultant wave. So if you shift a wave by 2 pi, you are shifting it by a complete cycle. So which is more like bringing every other position to where it was before. So the shift is not going to be different. A shift of 2 pi is not going to be different from the original wave. So if I superimpose that to the first wave there, I'm going to have a resultant wave that looks like this, which is just an addition. Each point was a +2 on the initial wave pattern, and now it's a +4. A -2 becomes a -4. So this is what would happen, and this is called perfect constructive interference, which happens when waves are superimposed and there's a phase difference of 2 pi or 360 degrees Celsius. How about if I say 180 degrees, which is half a cycle? What would happen? So if I superimpose waves that are shifted there by half a cycle, this is what would happen. And on each and every one of those regions, the waves are going to cancel each other out. +2 -2, +2 -2, and the resultant wave is going to be a straight line. And this is called perfect destructive interference, which occurs when waves have a phase difference of pi or 180 degrees. I hope this helps. This is basically what wave superimposition is about.